The world is just full of hidden patterns. They're everywhere, from how a flower grows to how the stock market behaves. And today, we're going to decode the simple mathematical rules that are kind of writing the script for everything around us. I know, it sounds like a weird question, right? But think about it. The height of these chairs, it follows a really predictable, repeating pattern. And the crazy part is, the exact same mathematical idea is what's behind the way your savings grow with compound interest. It all boils down to one simple concept, the sequence.
So, first things first, we've got to give these patterns a name. And in the world of math, we call them sequences.
So what exactly is a sequence? Well, it's really just a list of numbers, we call them terms, that follow a very specific rule. I love this analogy. Think of it like a mathematical conga line. Every single number knows exactly where to stand based on the one right in front of it. Okay, so these rules, they kind of come in a few different flavors. Let's dig into the two big ones you'll run into most of the time. So here are the two main types. On one hand, you've got the arithmetic sequence. This is where you just add the same number over and over again. We call that the common difference. Then, on the other hand, you have the geometric sequence. This one doesn't add, it multiplies by the same number each time, which we call the common ratio. It's really the difference between slow and steady growth versus something that just explodes. But of course, not all patterns are quite that straightforward. Some of them follow a totally different kind of rule. One that's actually beautiful in its simplicity, but shows up in the most amazing and unexpected places. I'm talking about the Fibonacci sequence. The rule is so simple, you just start with 1 and 1. Then, to get the next number, you just add the 2 that came before it. That's it. It starts off small, but it grows in this really unique way that, believe it or not, you see all over nature. And check this out. This is a seriously cool connection. If you take another famous mathematical pattern, Pascal's triangle, and you add up the numbers along these slanted, rising diagonals, what do you get? You get the Fibonacci sequence. It's just, wow. It's one of those moments that reminds you how all these different parts of math are secretly connected. Okay. So we have these lists of numbers, these sequences. But what happens if we do something different? What if, instead of just listing them out, we start adding them all together? Well, that's the moment a sequence transforms into something called a series. A series is literally just the sum of all the terms in a sequence. I like to think of it this way. If the sequence is your recipe's ingredient list, the series is the final delicious cake. It's the total result of adding everything up. And this, right here, leads to a really fascinating, almost philosophical question. What happens if the list of numbers just never ends? If it goes on forever? Can you actually add up an infinite number of things and get a real answer? I mean, is that even possible? The answer, and this is pretty mind-blowing, is sometimes yes. I know it sounds completely impossible, but let's take a look at how mathematicians figured out how to tame the concept of infinity. Okay, let's look at a classic example. Consider this geometric series. We start with 1/2, then we add a quarter, then we add an eighth, then a 16th. You see the pattern, right? Each new piece we add is exactly half the size of the one before it. So what do you think happens? If you could keep adding these smaller and smaller and smaller pieces for all of eternity, where would you land? Does the total just keep getting bigger forever, or does it actually zero in on a specific number? The answer is 1. Exactly 1. Not about 1 or getting close to 1. The sum is precisely 1. How amazing is that? Even with an infinite number of things to add up, the total is a nice, simple, finite number. Now, this little magic trick of adding up infinity doesn't always work. There's a catch. It only works if the terms you're adding get smaller, and get smaller fast enough. We have a name for this. It's called a convergent series. And for a geometric series, like the one we just saw, the condition is super simple. That number they're multiplying by each time, the common ratio, its absolute value has to be less than 1. But you gotta be careful, because not every infinite series plays by these rules. Take a look at the famous harmonic series. Here you're adding 1 plus a half plus a third plus a fourth. You get it. Now, even though the numbers you're adding are getting smaller and smaller, they're just not shrinking fast enough. This sum, believe it or not, will just keep growing and growing forever, all the way to infinity. And we call that a divergent series. Okay, so this is all a really neat mathematical puzzle, but so what? does any of this actually matter in the real world? Oh, absolutely. These ideas aren't just for textbooks, they are literally the hidden engines running a huge chunk of our modern world. I mean, in fields like physics and engineering, series are an absolutely fundamental tool. A lot of real world stuff is described by equations that are just ridiculously complex. What series lets scientists do is to break down those monster equations and approximate them with simpler, more manageable chunks. It's what makes a whole lot of impossible problems totally solvable. And these patterns are literally coded into the technology you and I use every single day. That formula for compound interest that makes your savings grow? Yep, that's a geometric series. Ever wondered how your calculator can instantly tell you the sine of an angle? It's not magic, it's using a series to get a really, really accurate answer super fast. Even the music you're streaming is just a complex sound wave that's been broken down into a series of simpler waves.
And it's not just in our technology. This language is written into nature itself. The way radioactive elements decay, that follows a geometric sequence. And remember those beautiful, perfect spirals you see in a pine cone or in the seeds of a sunflower? That is the Fibonacci sequence, right there in front of you, with the ratio of its terms getting closer and closer to the famous golden ratio. And that, to me, is the beautiful paradox at the heart of all of this. You can have an incredibly simple rule, like just add the last two numbers, and it can create endless, stunning complexity. And at the exact same time, you can have an infinitely long list of numbers that can be boiled down to a single, simple, finite answer. So, the next time you see something simple, like chairs being stacked, or you check your bank account, or you just look at a pine cone on the ground, I want you to remember the deep, powerful mathematics that are hiding just beneath the surface. The question is, what patterns are you going to notice now?